Section 5.3, example 14, using integral tests. So for each of the following series, use the integral test to determine whether the series converges or diverges. Assume that all conditions for the integral test are met. So starting off with this very first one, the sum as n goes from 1 to infinity of 1 over n cubed. All right, let's see. Integral test, so it has to satisfy 3 conditions. So the first one, f has to be continuous, and so we're saying that f of x is equal to 1 over x cubed. F is continuous because whenever n is equal to 1 or x is equal to 1, we have 1 and then it's continuous on its entire domain. The only time it's discontinuous is at 0, and we bypass that. 2, f is decreasing. So we'll call this as x gets larger, we end up with 1 over n cubed. These values get smaller and smaller and smaller and smaller. So f is decreasing. And then 3, we just let f of n equal a sub n. So this is going to be our function f. So then if the integral converges, then they both converge. If the integral diverges, then they both diverge. So let us see. So here we're looking at the integral from when n is equal to 1, we have 1 up to infinity of 1 over, we'll say x, 1 over x cubed dx. So this is a, like we have to, I forgot what it's called. So the limit as b approaches improper integral. There we go. So this is an improper integral. So we're going to let b equal infinity and go from 1 to b of x to the negative 3 dx. So the limit as b approaches infinity of, let's see, this is going to be x to the negative 2, and we're multiplying by negative 1 over 2. And we're evaluating from 1 to b. So this is going to be a negative 1 over 2 as the limit of b approaches infinity of 1 over b minus 1 over 1, which is just 1. So this ends up being negative 1/2 times negative 1, because this part goes to 0. So we end up with a positive 1 over 2. Positive 1 over 2 tells us that this converges. So this tells us that the integral from, what was it, 1 to infinity of f of n, or 1 over x cubed dx, converges, which means that the sum as n goes from 1 to infinity of 1 over n cubed also converges. And there we go. If you have any questions, please feel free to ask. Otherwise, oh, actually, no, not yet. We have another one. So B. So now let's look at this one. So doing the exact same thing here, integral test, let's integrate from 1 to infinity. So integrating from when n is equal to 1, let's see, 2 times 1 is 2, minus 1 is 1, the square root of 1 is 1, divided by, or numerator 1 is still 1. And infinity, we're still going to go to infinity. There we go. All right, and we're looking at the square root of 2n minus 1, 1 here. And actually, let's make it x, 2x minus 1, 1 dx. And improper integrals, so let's fix that. The limit as b approaches infinity from 1 to b, the square root of 2x minus 1 over 1 dx. And let's do a u substitution. So let u equal 2x minus 1. Du is equal to 2 dx. So we're integrating 2 are actually 1 over 2. The limit as b approaches infinity from 1 to b of u to the negative 1 over 2 du 1 over 2. The limit as b approaches infinity of 2 times u to the 1 over 2. Evaluate it from 1 to b. And when you plug 1 in, I kind of did this in my head, but I didn't say it here. When you plug 1 in, you end up getting 1. So this ends up still being 1. When you plug b in, you end up getting 2b minus 1. I mean, we could throw that in there. 2b minus 1. Making this 2b minus 1. Which in theory is still infinity, but we could still state it this way. So now evaluating these two divide out. So what we're looking at is the limit as b approaches infinity of u to the 1/2, evaluated from 1 to 2b minus 1. So what we have is the limit as b approaches infinity of the square root of 2b minus 1 minus the square root of 1. And this goes to infinity. So since the integral of f of x approaches infinity, we would say that a sub n also approaches infinity. So a sub n diverges. Sorry about that. You say a sub n diverges. And now there we go. If you have any questions, please do not hesitate to ask. Otherwise, bye.